RDT is pleased to introduce our first patented product, WearKnot Drill Pipe. Developed for today's unconventional shale drilling, WearKnot Drill Pipe has been utilized very successfully for 3 years now in very challenging and harsh drilling formations. Today, we will demonstrate how WearKnot drill pipe is made while focusing on the welding of the WearKnot midsection using our new 400BX inertia welder. The full-length green tube ends are first upset using our world-class 7 5/8-inch double toggle hot forged mechanical upsetter. The tubes arrive at the weld shop with both upset ends already turned and bored to final weld dimensions. The larger OD WearKnot section is placed into the spindle section of the 300BX welder, while the tube section is gripped behind the upset. The spindle will accelerate to approximately 1,220 RPMs before kinetic energy takes over due to the weight of the flywheel. As the drive motor is disengaged, the gripped tube will apply a predetermined pressure to the WearKnot, depending on the area to be welded. When the pressure is applied, friction elevates the two end areas to forging temperature, and they bond together, forming a weld area inside and outside the part called a ram's horn. While the weld section is still hot and gripped in the machine, a broaching bar will shear the internal ram's horn from the welded section. This section is extremely hard and brittle at this point and must go through a stress relief process using a heat induction coil to elevate the temperature to 1,250 degrees Fahrenheit in order to eliminate stress cracking by softening the weld area, allowing removal of the external ram's horn by machining the raised area without breaking the cutting tools. The part is then inserted into a manual lathe where the external ram's horn is machined down to the required OD. Next, the ram's horn material remnants are ground to a smooth surface inside and out. The joint of pipe continues down the production line to be sawed in half. The section with the mid-tube wear knot is then introduced to our new state-of-the-art first-ever through-hole 400BX inertia welder, designed and manufactured expressly for the WearKnot drill pipe manufacturing process. With the welded WearKnot section secured in the spindle, it is now ready to be welded to the other section of the tube. The upset end will be placed in the gripper and aligned for welding. The same inertia welding process is completed as previously demonstrated. Following the stress relief and machining of the second weld area, the internal ram's horn is machined off using an extended reamer head. The weld areas are then smoothly grinded internally and externally, removing any markings that might cause stress risers. The WearKnot midsection assembly returns to the upsetter to upset the two plain ends before going to our new heat treating facility, where the product will be heated, quenched, and tempered to very specific grade levels required by our customer. Finally, the box and pin tool joints will be welded on using the 300BX inertia welder, followed by ram's horn removal, heat treatment of the weld area, and final inspection. Our new 400BX welder complements RDT's dynamic machinery components currently used in our vertically integrated plant. The new innovative 400BX through-hole inertia welder ensures high-quality welding standards while expediting the process of WearKnot drill pipe for use in high-angle, lateral, extended-reach weld bores on and offshore. So when faced with challenging well bores of today's demanding oil and gas drilling requirements, why not WearKnot?